Hi everyone, my name is Lorna Haworth, and I will be presenting the project titled Median Treatment May Impact Wildlife Vehicle Collisions on California Highways. And first, I'd like to thank all my many co-authors, including various student interns and Caltrans for funding this project. So I first wanted to start talking about why it's important to understand factors that lead to collisions with wildlife. As wildlife researchers, we care about animal welfare and maintaining healthy populations. Roadways not only disconnect the landscape physically, but present a barrier to animals attempting to move. As transportation planners, road safety and prevention of collisions is prioritized for safety and reducing costs. The prevention of wildlife vehicle collisions serves both interests. Another project in our lab, which you'll see next, has modeled the estimate of mule deer killed in California annually with conservative numbers at around 44,000. A recent study cites that cars hit over 2 million deer each year in the US, and that's only deer. Countless of other animals, from small herpetofauna to large predators, are also at risk. But collisions with wildlife are not just an ecological problem, they're a societal problem. It's estimated that collisions with large animals cost over $8 billion in the US each year. They also kill about 200 people and cause about 26,000 injuries. What can we do about this issue? One solution is building wildlife crossings. Wildlife crossings are increasingly popular around the world to connect fragmented habitat. Overcrossings, like the image on the left, or undercrossings, like culverts in the right image, can be built or retrofitted respectively to make them appeal to wildlife use. Studies have found these structures can make a real difference reducing collisions and improving habitat connectivity. But we can't build crossings everywhere. In places where crossing structures aren't an option, we need to look at the roads themselves. Bridges, culverts, median barriers, and even vegetation can all influence how wildlife move or don't move through the landscape. By understanding how built infrastructure affects wildlife behavior, we can find ways to reduce road impacts and keep wildlife populations connected. This is where our research question comes in. Thanks to Caltrans, we were able to explore how road infrastructure, specifically road medians, influence wildlife vehicle collision rates. To clarify, a road median is the space between opposing lanes of traffic. Here, we'll go over the different types, which have varying levels of permeability. Concrete barriers may be the least permeable to wildlife, acting as a physical and visual barrier to wildlife at the roadside. Metal beam guardrails and cable barriers may be more permeable, as animals can see through them and crawl or jump over them. Unprotected medians, like painted stripes or undeveloped gravel or vegetated strips, may be the most permeable as they don't physically block movement. Transportation planners often select different median types based on state guidance to reduce crashes and prevent head-on collisions, but can cause and fatalities. Concrete barriers prevent head-on collisions, but can cause more injuries to humans. Cable and metal beam guardrail barriers cause fewer injuries to humans, but only deflect cars from crossing the median. So we used two approaches to test our question. In the first, we used Google Earth imagery to select median transects and then conducted field surveys for these pre-identified transects. The second approach used existing roadkill data from the California Roadkill Observation Network, or CROSS, and then we did statistical modeling in R. So first, let's break down some of the things I just mentioned in the methods. CROSS, which is, again, the California Roadkill Observation System, is a roadkill data set in which records include roadkill and injured animals on roads throughout the state. The data is sourced from state agencies, community science groups, and user-submitted observations. After our roadkill driving surveys, we submitted all of our data to CROSS. Now for the median barrier data. Unfortunately, there is no existing data set that we could access. So instead we use Google Earth to virtually go to collision sites and record what median type was at that location. So here is a photo of Interstate 80 near our research center in Davis, California. The white pin on the left photo corresponds to a wildlife vehicle collision location, and the picture on the right is the street level view. So in this example, the median type would be metal beam guardrail. And here's an example of the paired transects that we used for our field surveys. So in Google Earth, we found points on highways where one median type transitions to another, and the land use was similar on either side of the highway transition point. In this example, the median type transitions from concrete to metal beam guardrail. From the transition site, we measured 1 to 5 miles in either direction where the median type was continuous, and these are what formed our study transects. We drove along 24 of these transects, recorded all roadkill observed, and added those observations to cross. With this collision data set, we compared the wildlife vehicle collision rates between the transects within each pair, where the rate was weighted by transect length. And we found that across all pair types, there were no significant differences in collision rates. But some pair types had a few transects, and collisions were concentrated in just a few pairs. With a larger sample size, we may be able to detect a difference. However, this method is fairly time-consuming to get all the roadkill data, so we turn to our existing data set, CROSS, for our next method. This is method 2. We looked at collisions of select species at a district-wide scale. These districts are defined by Caltrans. We used districts 2, 4, and 9 due to sample size. For study areas, we generated random points along highways where collisions were reported to serve as a control data set to simulate where roadkill did not occur. So for every one roadkill point, we simulated exactly one random point. For each species, we selected a large mammal, mule deer or black-tailed deer, a medium mammal, coyote, and small mammal, we used western gray squirrel for 2 districts 2 and 4, and then black-tailed jackrabbits for district 9, and that was just due to differences in sample sizes. We needed enough, so we had to use jackrabbits for 9. The black dots on the map in each district show the collision sites for deer, and the total sample size of this roadkill and simulated data set for deer was 5,586, coyote was 944, and the combined squirrel and jackrabbit were 872. So we use linear modeling with HIT as the binomial response variable. HIT represents the probability that an animal may be injured or killed by a vehicle. In all models, we used median type as the first predictor and then added various distance to land cover measurements as additional predictors. We tested the predictors for correlation amongst one another. The results of the correlation matrix are represented in the plot on the right. Using a cutoff value of 0.6 and above, we removed the distance to open water and wetlands combined predictor since it was considerably correlated with the distance to wetlands predictor. It had a correlation coefficient of 0.94. We also tested for multi-collinearity using the variance inflation factor. None of these values were abnormally high. And then we also tested the models for over-dispersion, and none was detected. Okay, so now we'll get into the model results. We found that across all species models, median type was always the best predictor of wildlife vehicle collisions. But we want to know which median has the greatest or smallest effect on roadkill. The following results and graphs are an attempt to answer that question, but spoiler, it gets kind of tricky. So let me explain this graph and hopefully it'll come together. So here are the deer results on a log odds plot or log odds ratio plot. The log odds ratio value is along the x-axis and the predictor categories are along the y-axis. If the ratio is larger than 0, there is a positive effect or association of roadkill, shown in blue. If the ratio is 0, there's no effect. If the ratio is smaller than 0, there is a negative effect or association, shown in red. So blue is associated with increased roadkill probability, while red is decreased roadkill probability. Since there are two types of data among the predictors, categorical for median type and continuous numbers for the distance to data, they're compared differently in the model. Categorical variables are compared against a reference predictor, in this case, painted stripe. Numerical predictors are compared against 0. The error bars represent the 95% confidence intervals, where some median types have fairly wide intervals, which indicates uncertainty in the results. However, I think this could be addressed with larger sample sizes within each median group. Some of them were pretty small. In a logistic regression, the intercept represents the log odds of the outcome. So I ran a post hoc ANOVA test to find statistical significance for each predictor, and that's indicated by the black stars on the graph. This graph tells us that when using painted stripe as the reference category, the other median types are associated with less wildlife vehicle collisions. So cable is associated with the least number of deer wildlife vehicle collisions. And you'll see that the distance to land cover predictors are all fairly close to 0, which means they have a relatively small effect when compared to the median types. However, some of them are still significant, as indicated by the stars. We also ran post hoc pairwise comparison between every median type combination. Only the significant results are shown. An odds ratio greater than 1 means higher odds for the first group, while an odds ratio less than 1 means a lower odds for the first group. And then equal to 1 would mean no. There's no difference between the two groups compared. For example, between painted stripe and concrete, the odds of a wildlife vehicle collision is 1.8 times more likely at painted stripe. Okay, so now the coyote results. When using painted stripe as the reference category, the other median types are associated with more wildlife vehicle collisions. Based upon the coefficient value, metal beam guardrail is the predictor most strongly associated with coyote wildlife vehicle collisions. And those are the significant predictors. Again, similar trend with the distance to data. And then these are the results of the combined squirrel and jackrabbit model. When using painted stripe, again, as the reference predictor, there are less collisions at all other median types. And similarly with the stars, and a similar trend again with the distance to land cover data. So we found that yes, median type is a significant predictor of wildlife vehicle collisions for deer, coyotes, and western gray squirrel / black-tailed jackrabbits. However, when we try to parse out the differences between median types for a species, the answer is somewhat trickier. Due to large sample sizes due to small sample sizes within median groups, some results are not robust enough to determine with certainty which median type is better for one species than the other. For deer and squirrels and jackrabbits, median types seem to decrease likelihood of roadkill. However, for coyote, median type appears to increase likelihood of wildlife vehicle collisions. This leads us to believe that different species interact differently with median treatment types, perhaps due to body size or hunting strategies. Future research should be aimed at understanding the mechanism driving wildlife behavioral responses to median types, camera traps to document wildlife behavior when approaching the road, collar data to evaluate animal movement patterns, and DNA samples at medians could all be used to better explore this question. I'd like to again thank all my co-authors, Caltrans, NCST, and others for help with this project. Thank you very much. These are some sources.
Well done, Lorna, again, in right on the time. So,
Perfect.
perfect. 2 for 2. All right, a couple of questions for Lorna. We'll go to the side this time.
I hope I didn't miss it and you said it, so forgive me if I did. But in your study and, in these comparisons, did you look at speed?
Speed of the road?
Yeah.
We haven't, but that's definitely a good suggestion as I'll continue to work on this project. Keep that in mind. A big issue for this is usually having a data set associated with the highways throughout the state, so might be an access issue. We'll see.
Do we know anything about where different types of mediums are constructed and why? Like, maybe concrete where there's on a bend or.
Right. I think they're typically decided at a more local level, so you can't make any generalized assumptions at the statewide scale necessarily. But I know that traffic data and crash reporting is used to determine that. Obviously, concrete barriers are the best for preventing two cars from colliding with one another, but it's inconsistent, I guess, is the most simplified answer I could give you.
Yep, coming over there. Got time for a couple more. Okay.
I may have missed this too, but did you exclude areas or how did you treat areas that had side rails while keeping around? And then
Sorry, you mean on the sides of the roads?
Yes.
I don't think we necessarily excluded something unless it was a very large barrier, with the assumption that wildlife could still jump over or crawl underneath a fairly open type of rail situation. But if it was like a tall concrete wall, those are not included in the analysis.
Okay, and then my second question is, both the slide with, it seems like the metal guardrail is kind of a bugaboo. And so do you think that animals it's enough to not be a full deterrent like a concrete rail, but that they're getting in because they're just tempted enough to get through and try to get through?
Right.
What is your interpretation of the metal guardrail being the works?
Yeah, that's kind of our reason. What we were thinking is that maybe wildlife can see to the other side, and so they see that as potential habitat and want to cross with a semi-permeable median type, and so in attempting to cross, they get killed.
All right, with the back row back there are multiple questions, so you're gonna have to be quick.
Mine is not even a question, but it's congratulations for what you have done.
Thank you.
Studies like these have made us think how you select the median type. And on the state route 14, we are doing median selection where we put an opening under the median so that amphibians, apes, all that can go under it. So studies like these are helping. That's what I want to say. Thank you.
Excellent. Thank you.
Thank you. Way to go, Lorna.